This is Populations and Resources Lesson 1.4, Activity 3. So to make their thinking clear, scientists often use models to show their ideas about how something works. So in this unit, you will be using a visual model called a modeling tool to show your ideas about why populations change size in an ecosystem. So the modeling tool that you will be using will look like this. So populations are represented in the modeling tool um, by this circle. So the moon jelly population on the top is when the moon jelly population is stable, and then the bottom circle population represents when the moon jelly population is increasing. So each box in the circle represents an individual organism in this population. So this model initially shows just 6 moon jellies in the population, and of course there are many, many more moon jellies. But in this simplified model, you're going to use small numbers to show basic ideas about how population changes size. So if we look at the key on the bottom left, we can see that a box represents an organism in a population, and that a crossed out box shows that there was a death, and then a new box with a B inside of it shows that there was a birth. So I need to figure out how many births and deaths to show for a stable population. So I'm going to go to this example here. So in a stable population, I want to show how many births and deaths I should write down. So as the key in the model explains, to show a birth, I want to draw a box, a new box. See how it's in red? It's a new box with a B in it. And to show a death, I would cross a box out that's already there. So we're saying that one of the initial 6 has died. So we put a X in those boxes. And then a birth is saying that there's a new box, and we show that with a B. So there's 6 moon jellies in the population when it's stable. So if I want to show the same number of births as deaths, I could add 2 boxes with the B and 2 boxes with an X. So 2 births, 2 deaths. And then we could still see that I have 6 total. So these are 2 deaths. I still have 1, 2, 3, 4, 5, 6. So if I wanted to show more deaths than births, I could cross out one more. And if I wanted to show more births than deaths, I could add one more box with the B. So it's not important exactly how many births and deaths you draw, but it is important to show how the number of births compare to the number of deaths when a population is stable or changing. So if I want to show it stable, then the population size needs the same. So we need to have about the same number of births as there are deaths. What you're going to be doing is you are going to be modeling a stable range and an unstable or increasing range. So that is why there's 2 here, because we're trying to show how the moon jelly population has changed from 1980 to 2010. And we know that between 1980 and 2000 it remains stable. It's roughly the same, but then from 2000 on it increases. So we're going to be modeling when it's stable and then also when it's increasing. Now to do this in class, I would be having you download this to Notability, or some teachers might be giving you a piece of paper. Obviously we can't do that right now in the same way. So what you need to do is you're going to need to go to Canvas. And in Canvas, under the same lesson, so we're in Populations and Resources, lesson 1.4, activity 3, it's going to tell you to watch this video, follow along with the instructions to complete this activity in Amplify. And when prompted, and I'm prompting you right now, this is me prompting, is for you to download this into Notability to complete the modeling tool. And then when you finish the modeling tool, You need to turn it back into Canvas. So I always name my Notability notes, which is what the name, this blue link is what it will be called. I always name it the same name as the assignment, so that when you're going to turn it in from Notability to Canvas, all you have to do is look at the name of the article of the note in Notability, and that's the name of the assignment you'll be turning it into. So again, to complete this modeling tool, you need to go to Canvas, lesson 1.4, activity 3. You need to download this into Notability, do it in Notability. The instructions to do it are in 1.4 activity 3 here. And I also just showed you how you would do it. And when you're done with that, turn it back into Canvas. So go to Canvas, download that to Notability, do the activity using the instructions here on 1.4 activity 3, turn it into Canvas, and then come back to the. So now that you've completed the modeling tool in Notability and turned it into Canvas, we're going to talk a little bit about what you did. So when the jelly population was stable, the number of bursts had to equal the number of deaths. So it doesn't matter how many bursts or deaths you put, as long as they are equal. Now, when the jelly population is increasing, there has to be more bursts than deaths for the population to go up. So there's a couple different ways that you can do this, and this is going to be a really important component of this unit, is to understand this right now. This is really a critical moment in, if you don't listen and try to understand this and ask questions, if you're not getting what I'm saying right now, you're going to have a hard time in the rest of the unit. So the sim and the token activities you did showed us that for a population to increase, there have to be more bursts than deaths. This can happen because there is an increase in the number of bursts in the population, because there is a decrease in the number of deaths, or both. So we need to learn more about what can cause bursts to increase or deaths to decrease, and gather evidence about which of these might have been happening in the population. So to explain that further, we can see that claim 1 says that bursts increased. So let's start off with stable. Okay, stable means there's the same number of bursts as there are deaths. The population doesn't change. But we're trying to show it increased. So it can either increase, where we have more bursts than deaths, because the births increased. So in this scenario, we have one extra birth and the deaths stayed the same. So because we have more births than before, but the deaths stay the same, we still have an increase in population. So now we have 1, 2, 3, 4, 5, 6, 7. So births have to be greater than deaths for populations to increase. And one way for births to be greater than deaths is for births to increase and deaths to stay the same. Now claim 2 is saying that one way for births to be greater than deaths is if the deaths decreased. So in this scenario, when the population is stable, we have the same number of births and the same number of deaths. But what is showing it's after is that the way that births become greater than deaths is that the deaths decrease. So we have one less death than before, but we have the same number of births. What's important for a population to increase is the births must be greater than the deaths. So same thing here. There's 2 births and 1 death, so there's more births and deaths, population increase. Claim 1, there's 3 births and 2 deaths, so there's more births than deaths, and the population will increase. Scenarios, the population increases, but they're due to different reasons. So we're going to have to continue to gather evidence to determine whether the moon jelly population increase was caused by more deaths or caused by fewer deaths since the year 2000.